The Alonzo Blue testnet is currently in full swing, and we're starting to hear from developers. It's really looking like Cardano's Plutus smart contract language is going to crush Ethereum Solidity. Ready? Let's go. We now have the mid-month update that tells us exactly where we are on the Alonzo Blue testnet. But before we take a look at that, we've also got this first-hand account from MinSwap of what it's like to build in Plutus. They're creating a DEX in Cardano. In this long and detailed post, MinSwap points out that we've all heard over and over and over again how Cardano's smart contract programming language, Plutus, is going to be better and safer than Solidity. But we haven't actually heard from many of the developers who are actually building something on Cardano. One of the first things that MinSwap points out is that Plutus is really Haskell. Plutus is written in Haskell, which means that you're using a language that has decades of development and stability behind it, instead of the scenario in Ethereum where they've created a brand new language that doesn't have that history of testing and stability and development. Because Haskell is an established language, that means there's a lot of stable tooling and libraries that can be utilized from day one by developers, including Quickcheck. Here's Quickcheck for you, described on this page as a library for random testing of program properties. The developer provides a specification of the program in the form of properties which function should satisfy. You should know that Haskell is a functional programming language. And Quickcheck then tests that the properties hold in a large number of randomly generated cases. And look at the number of versions of Quickcheck they have gone through over here. This is not a brand new tool. This is a stable tool that developers can rely upon to test their programs. MinSwap contrasts that with the landscape in Ethereum Solidity, a language made up for that blockchain, where a developer only writes tests for a few scenarios and doesn't have this sort of little, MinSwap calls it a test monkey in Quickcheck, that randomly plays with a smart contract a few thousand times to see if it breaks. There's a significant difference in those two testing scenarios described by MinSwap here. MinSwap also points to something we've covered on this channel many times, and that's that Ethereum doesn't have native tokens, whereas in Plutus, all tokens are native. And MinSwap describes a situation in Ethereum leading to the ugly wrapping and unwrapping of tokens in many cases. That doesn't happen in Cardano because they're all native tokens. If you don't know what a wrapped token is, this very short explainer from Binance is almost as good as any. A wrapped token is a tokenized version of another cryptocurrency. It's pegged to the value of the asset it represents and typically can be redeemed for it unwrapped at any point. It usually represents an asset that doesn't natively lie on the blockchain that it's issued on. And therein lies the difference between Cardano and Ethereum on this point. On another point we've covered thoroughly in the past, extended unspent transaction output accounting seems amazing compared to the Ethereum situation with account balance accounting, because eUTXO can predict transaction fees accurately, and users don't end up paying fees for failed transactions. MinSwap points out it also prevents this whole genre of problems in Ethereum that involve minor extractable value. Minor extractable value is such an obvious and predictable problem in Ethereum that the guy who wrote this article actually predicted it before the Ethereum Genesis block in 2014. PMC Goguen wrote this article just a little bit ago on May 10th. He wrote this article following up something he predicted even before Ethereum had its first block, right? So minor extractable value is something that sounds like it's pretty complicated, but it's pretty easy to understand when you approach it the way we're about to discuss it. This term, minor extractable value, MEV for short, was coined by some Cornell researchers in a paper they did called Flashboys 2.0. One of them was actually the co-author of this article right here. So they sum it up well. Basically, when a miner is including transactions in a block they have the luxury of sequencing those transactions so that they see if you were about to buy a token. If you're about to buy a token, they say to themselves, hey, this person is about to buy this token. What I could do is I could buy the token first, sequence my purchase first, then put their purchase behind it, and then another transaction by me where I sell the token. So I'm going to buy it, and then you're going to buy it, and then I'm going to sell it, right? And they're doing this because they know that your transaction is going to raise the price of the asset, right? When there's a purchase of an asset, barring any other variables, right? That's like an increase in demand of the asset and the price can go up. So what they do is they buy some of the asset knowing that your purchase is going to make the price go up. Then your purchase makes the price go up and then they sell it. So they make money in between their first trade and their second trade. The problem for the user is that their first trade also makes the price go up a little bit. And they sort of position their first trade so that your trade will still go through. So they make their trade, which forces the price up a little bit. And then you end up paying more than you should have, more than you would have without their initial trade. Then your trade pushes the price even higher. And then their final trade, they sell and they make money. So they make money and you lose money on your purchase, right? This is the kind of front running that was discussed in the equities markets with certain app-based trading platforms where the characterization, at least, was that the user data, the data on the user's trades, was being sold off to institutions so that institutions could front run those trades. But this is crypto where we always try to outdo the rest of the legacy financial system. So they took it a step further. They got really exotic with the miner extractable value. And they even tried to convince Ethereum users that because front running through miner extractable value and other forms of miner extractable value were inevitable, we should just have front running as a service where we just front run it. It's all open and we front run your transactions and, it takes various forms, but maybe it's an auction where the value is like officially extracted and we auction off the right to front run, whatever transaction you're doing. This is how bad this has gotten in Ethereum. So you can understand why MinSwap is excited here when they say eUTXO is amazing because it allows you to predict transaction fees. You don't have failed transactions, and it prevents this whole genre of problems involved with miner extractable value. This is no small thing. Another really interesting thing is that the Ethereum blockchain is more than 300 gigabytes of data now. Obviously, the Cardano blockchain, a little bit younger, but all of these blockchains will grow to large numbers, one day. On the Ethereum blockchain, they only store the hash of a script, which means no matter how complicated the script is, it takes the same amount of space. Here's what we mean by that. For anybody unfamiliar with how hashes actually work, I highly suggest this little infographic in the Wikipedia entry for cryptographic hash functions. So the way it works, if your input, so the input is kind of like it's the input into a cryptographic hash, and the digest is kind of like the output. But here's the interesting thing about hashes, right? If I just have the word Fox, it puts out a digest, an output with this many little placeholders, right? This many digits. If I put in a much longer phrase, it's the same length. If I put in a different phrase, it's the same length, right? And this serves several different functions, but for purposes of this discussion, the awesome outcome of this is that you could have an extremely, extremely complicated and long input. And if you store that as the hash, it can be the same exact length as a very, very simple contract. So obviously, if you have a blockchain full of extremely complicated scripts, storing them as hashes only could allow you to compress that data and the blockchain wouldn't have to be so big in terms of storage. So MinSwap, an actual developer actually developing a DeFi product in the Cardano blockchain, sums it up like this. In conclusion, the long years of researching and building from scratch has yielded results. What we have now is a better, faster, and safer smart contract platform. Speaking of all the researching and building, we also got the mid-month update from IOHK, which told us exactly where we are on the Alonzo Blue testnet, which through its various color-coded iterations will eventually bring us Plutus and smart contracts. You remember from our previous coverage, IOHK was supposed to be able to hit a code freeze at the end of June and then allow July and August-ish for all the exchanges to catch up. And then we might have a launch of Alonzo, maybe the very last bit of August into September. I'm guessing, just given the way crypto development works, I'm guessing like, first part of October, because I'm a realist. But, optimistically, the roadmaps they keep showing show it even as early as late August. So it actually looks like things are going right on schedule. So we learned in this update that the very first smart contract ran on the Alonzo Blue testnet on Tuesday, and that right now they're basically working on what they're calling hello world round trips, where they basically run a very, very simple script, right, through a node to the ledger, back to the node. The Plutus partners working in the Alonzo Blue testnet. So the Plutus partners are third-party functional programming development firms, right? Really good Haskell developers. This is the list of current Plutus partners: Alt Labs, D Quadrant, Elex, MetaLamp, M Labs, Node Factory, and Obsidian. And we saw interviews with some of these folks in the Cardano 360 episode. They all seem like the most capable Haskell developers you could possibly find, basically. And they're all working on use cases that could be ready for the launch of Alonzo. Here are some of those use cases: Oracle implementation, DEX token swaps, liquidity and stake pools, lending pools, crypto-backed stable coins with staking, which we covered yesterday, NFTs, and exchange building. So it's a little bit ambiguous, but I believe we've seen hints in the past that they're doing something really smart, and that's sort of assigning each of these outside development firms to focus on a certain area. So if I'm understanding correctly, each of those would be focusing on sort of like just one of these areas or maybe a couple of these areas, which is great because they've got a little bit of time and they can sort of get the gears turning on development of these use cases, so that I don't think anybody's saying that they'll actually necessarily have something ready on Alonzo launch day, but who knows? I think this sort of like parallel development that's always going on in Cardano is one of the super smart things, right? They don't do everything in sequence where they build something and then like, okay, now start building out dApps to work on top of what we just build. They've actually got these really high level developers from these development firms around the globe already working on these things, which will ride on Alonzo before Alonzo even launches. So one of the many smart ways in which Cardano is constantly getting ahead of other projects. These kinds of updates always make me super happy to be in this ecosystem, and I will talk to you tomorrow.